Okay, here's the tricky trig problem. Two parts to it. We've got a triangle A, B and C, those are the angles, and it's given that we've got some information, 2 bits of information about linking angles B and C together. So 4 sine of B plus 3 cos of C is 6, 3 sine of C plus 4 cos of B is 1, show that B plus sine of B plus C is a half, and then show that there's only one possible value of A, not the 2 that you might expect. Okay, so if we square and add both of these, we get 16 sine squared of B plus 9 cos squared of C plus 4 times 3 times 2 times sine of B times cos of C, which is 24 sine B cos C, and there's the 9 cos squared C. Then we get 9 sine squared C, and we get 4 cos squared B, and we get 3 times 4 times 2 sine of C cos of B. So that's 24 sine of C cos of B, and there's the 16 cos squared B. And 6 squared is 36, 1 squared is 1, add them together we get 37. So 9 sine squared C plus 9 cos squared C is just 9, because sine squared plus cos squared is 1. And 16 sine squared plus 16 cos squared of both of B is 16, again because sine squared plus cos squared is 1. And then we've got 24 is a factor of sine B cos C plus sine C cos B, and that's equal to 37. So we can simplify, can't we? The sine B cos C plus sine C cos B is just sine B plus C. 37 minus 9 minus 16 is 12. So there we have sine B plus C is a half, as required. Okay, so the second part, show there's only one possible value for A. Well, we know that sine of B plus C is a half, so B plus C is either 30 or B plus C is 150 degrees. And we're going to do 1 take away 2, equation 1 take away equation 2, and rearrange it. So 4 sine of B minus 4 cos of B, take away 3 sine of C minus 3 cos of C is equal to 6 minus 1 is 5. And we're now going to switch this part and use the format of our sine theta minus alpha for these. And when we find r and alpha, we've got 4 root 2 sine of B minus 45 degrees, take away 3 root 2 sine of C minus 45 degrees, and that's equal to 5. And then if we consider these two angles, this one must be positive to give a 5, with this one being a negative to give a 5. So that must mean that this angle must be, or the sine of that angle, B minus 45, must be positive, and the sine of this angle must be negative. So that means that B must be bigger than 45, and C is less than 45 to give a negative angle, because the sine of a negative angle, C minus 45, is negative, so the sine of a negative angle is negative. So take away a minus is the same as adding a positive. That's how we get 5. So B plus C must be equal to 150, because if the only way to get B plus C is equal to 30 is either if one of them's negative and the other one's bigger than 45, or they're both less than 45. In fact, they've both got to be less than 30, haven't they? And so we can't have this one. So B plus C must be equal to 150. Therefore, A is equal to 30 degrees.